Geographical Information Science, or GI science, is the science of dealing with spatial data and spatial issues. It's based on the basic geographic concept that many environmental and human processes are determined by spatial interaction. So spatial interaction is the movement or flow of goods, people or information from place to place. Spatial analysis allows you to problem solve issues and better understand what's occurring in our world. Much of the understanding of what and how analysis can effectively be done stems from an understanding of the underlying GI science principles. Effectively, you can't really drive unless you know the rules of the road. So analysis is the systematic examination of a complex entity to provide new information from things that are already known. For example, we can use land use, topography and transport to help us choose better sites to site businesses. And then we can go a stage further. We can analyse the distribution of the demographics of the population to find where those businesses will be successful. So using analysis, you have to break down the problem into the key components, into the things that actually matter, whilst including enough information so that you actually see the whole picture. Using spatial data, you know both what is present and where it is. So spatial analysis can be about just the analysis of locations, but more often than not, it's the analysis of both the locations and the characteristics of those locations. A Geographical Information System, or GIS, is the tool that we use to capture, store, process, analyse and visualise spatial information. A GIS implements many of the concepts of GI science. So the more you understand, the quicker you'll get to a solution. Even just a grasp of the basics, you'll quickly find spatial analysis a lot easier. In a GIS, each type of geographic data is stored as a separate layer. That could be houses, roads, population layers. So a GIS allows you to explore different questions and hypotheses using these different layers together. There are many forms of spatial data. There are shapefiles, KMLs, geodatabases, fusion tables, even just tables with coordinate information. But whatever the format your data is in, all spatial data can be mapped because you know where it occurs. So spatial data give us a means of representing the world. So using spatial data to represent the real world, we're actually creating a conceptual model. And therefore you have to decide how to best model reality. This is often the first decision you need to make as a spatial analyst. You need to consider both what you're modelling and why you're modelling it. What are the phenomena of the data that are important to your analysis? What are you going to be doing with that? What questions are you asking of that data? Of course, the nature of what you're modelling will slightly influence how it's best represented. So the natural environment is often represented as continuous data using raster grids. The built environment and administrative data tends to be modelled using discrete units as vector data. So in raster data, your real-world entities are regular grids, just like we see in digital photographs. In vector data, we're using three basic shapes of points, lines and areas. These are usually called polygons, and this is just like street maps. Information that describes what's known at any location is called attribute data. So spatial data can represent anything as long as we know where it occurs. So therefore the attribute data can take many different forms. It can simply describe the features, such as the name of the road, for example Thunder Road, or the administrative areas like Darlington County. They may be identified into different types of data, classified, so road type or land cover type. It may represent counts, such as populations or numbers of vehicles. It might be information on intensity, like average income or slope. Or it could be fluxes between different locations, such as traffic flow or dispersion rate, such as we use in air pollution. So all spatial data has a location. And using GIS, all spatial data is mapped. Being able to visualize data by location can be really valuable, both as part of your analysis and when you want to share your results. By learning some of the GI science concepts and using GIS tools, you'll be well on your way to simplifying real-world complexity, to better understand and solve geospatial problems.